Hello students, welcome back to the second video of this playlist. So in this video we will be solving the second question from October 2023 Statistics 1 paper. So let's see what's the question number 2 from October 2023 Statistics 1 paper is about. So basically the concepts behind question number 2, it's from chapter number 4, that is chapter number 3, that is representation of data. To be more specific, you should have idea about box plots and stem and leaf diagram. You can see on the figure on the screen there is a stem leaf diagram, so we need to deal with stem leaf diagrams, and also some concepts from chapter number 2, that is measures of spread and location. So like finding out the medians, quartiles, these stuffs. So let's get started with question number 2 from this paper. So the weights to the nearest kilogram of a sample of 33 red kangaroos. Okay, there are 33 red kangaroos taken in December are summarized in the stem and leaf diagram below. So you can see a stem leaf diagram here. So the key is that 3:1, it represents 32 kg. Okay, fine. This is the interpretation for the stem and leaf diagram. So in part A, the question asks to find the value of the median. Part A, number 1, the value of the median. We need to find out the value for the median. Okay, so median is basically the data value that lies on the 50th percent, right? 50th percent of the whole data. So that means 50th percent of the whole data, it is dependent on the total number of data, which is what? 33. So let's find out the median. For median we need n/2th term, right? Okay, so let's find out the median for part A, number 1. Median Q2 equals to what? n/2, that is 33. N is 33/2, which is 16.5. Okay, so here you can see that the total number of data is what? Odd. 33 is an odd number. So since it's odd, that means what? The median will give the median value that will give us the th term. What th term of the median value? It will give us in what? Decimal. So it's clearly written in chapter 2 for median. If the total number of data is odd, then you will get a decimal value for the nth term of the median. So if you get a decimal value, then we need to round it up. Always round up. That means 16.5, it should be what? 17th term. Okay, so Q2 is equals to what? 17th term. So let's find the 17th term from the stem and leaf diagram. So the first 1, 2, that is 3, 6, 13. This is 13, cumulative 13. So 13, 14, 15, 16, 17. 17 is basically what? 57. So median is what? 57 kg. Median is 57 kg. Okay, this is part 1. Part 2, what they have asked for part 2, the value of Q1 and the value for Q3. That means we need to find out the lower quartile and the upper quartile. Same process for Q1. Q1 is the lower quartile. Lower quartile is basically the 25th percent of the data, right? The data which lies at the 25th percent of the whole data, this is the lower quartile. So it will be what? 1 n/4. 25% is what? 25/100, which is 1/4. So 1/4 of what? Total number of data, which is 33, which will give you 33/4 is basically 8.25. Okay, 8.25, which will be also what? Rounded up. That is the 9th term. Okay, so the Q1, the upper quartile, the lower quartile Q1 is what? The 9th data. Which one is the 9th data value? 1, 3, 6. right? 136 7 8 9. So this is basically 45 kg. Okay, this is 45 kg. Okay, now what? Q3 is what? Q3 is basically the 75th data, sorry, 75th percent data, the data which correspond to 75th percent of the whole data, which is what? 75% is 75 over 100, which is 3 over 4 of 33. The total number of data is 33, which will give you basically 24.75. So we got decimal value always round up. So this is 25th data. Okay, so what's the 25th data from the stem leaf diagram? Let's figure it out. So till this is 13 and 8, this is 21, 22, 23, 24, 25. So we need 25th data. So this is basically this one, 63. Okay, so Q3 is basically 63. So Q1 we got 45, so Q3 is basically 63 kg. That's it. Okay, next for part 3. Okay, for part C, for next part B, for this data, an outlier is defined as a value that is greater than 1.5 times Q3 minus Q1 above the upper quartile, okay, or smaller than 1.5 times the interquartile range below the lower quartile. Okay, so this is the limits for given for considering outliers in this data. Okay, so part B asks to show that there are two outliers for these data. Okay, we need to figure out the outliers. Fine. So in that case, we need to find out the limits for the outliers at first, the upper limit and the lower limit. So let's find it out. The upper limit for part B. At first, let's consider the upper limit. For upper limit, this is what? 1.5 times the IQR, the interquartile range above the upper quartile, right? So 63 is the upper quartile plus 1.5 times what? 63 minus the lower quartile, we got 45. It is 45. So the upper range is what? 63 plus what? 1.5 times 63 minus 45. So this will give you basically 75. So upper limit is 75. Okay, upper limit is 75 kg. Okay, and lower limit, so upper limit is 75 kg. So let's see whether there are any values greater than 75 or not. Above 75, there you can see we got 12 plus 63, which will give you 75. So above 75, we need to check out whether there are any values or not. Okay, whether our value was correct. 75 is 63. Oh, 1.5 times 8, right? So 1.5 times not 8, this is 63 minus 45 gives you 18. 18 times 1.5, this is 27 plus 63, it is basically 90. It's not 75. Okay, it is 90 kg. So upper limit is 90 kg. Okay, let's check out from the data. Yeah, there is 94 is greater than what? 90, right? So 94 is an outlier. Okay, now consider the lower limit. We need to show that there are two outliers in this data. So this is 45 minus what? 1.5 times what? 63 minus 45, right? So what would be the value? 45 minus 27, it will give you 45 minus 27, this is basically 17, right? It's basically 18. So lower limit is basically 18. Okay, so let's see whether there are any values below 18 or not. Below 18 there is, yeah, 16. Fine. So what, 16 is basically an outlier. So 16, the lower limit is 16 kg, so 16 is an what, outlier. Okay, hence what we can say, there are two outliers in the data. That's what they have asked to show, isn't it? Done. Okay, next is for part C. For part C, before part C they said something. Figure 1 on page 7 shows a box plot for the weights of the same 33 red kangaroos taken in February earlier in the year. Okay, so in figure 1 of page 7 you can see a box plot given for these 33 kangaroos, which is representing their weights on the month of February. Okay, so here we are dealing with the weights of these 33 red kangaroos in the month of December. Okay, so part C asks to draw a box plot to represent the weights of these red kangaroos in December. So we need to draw the box plot for the what, for their weights in the month of December. Okay, so this is box plotting. For box plotting, what we know, box plot basically represents what, the range of the data, outliers, and most importantly the quartiles. So do we know the three quartiles, the lower, upper, and the middle? There is the median. We know Q1, Q2, Q3, all the three are known. So we know the range, the upper value, the lower value from the stem leaf diagram. So we can easily do the box plotting, isn't it? Okay, so right at first we have an outlier which is 16, right? It has been what, cleared from the data. So 16 is an outlier. So lower range is basically 23. Since 16 has been considered as an outlier, so 23 would be the lower range. Okay, so consider the box plot. Look, for the box plot, at first where it will start, 23 is given as here. Look, 21, 22, 23. This is the what, 21, 22, 23. Okay, this is basically the range, the lower range. Okay, then Q1 we got 45. Remember, we got 45. So this is basically the Q1, 45, right? This is at the middle between 40 and 50. This is basically what, Q1. Then Q2, the median. Remember, we got the median. What was that? Q2 was 57. Okay, Q2 was 57. Okay, so at 57 there would be a vertical line, right? 57. Where is 57? Here you go. This is basically the 57. Okay, and then the upper limit we got, which is 65. If I'm not wrong, that was 65. It's in this page. 63. Okay, the upper limit is basically 63. 61, 2, 3. Here you go. This is 63. Okay, 61, 62, 63. Okay, and the upper range is basically, there is an outlier. 94 is an outlier, so upper limit would be 86. 94 has been considered as an outlier, so upper limit is 86. So 86 is the upper range. So here you go, 86 is there. So this is basically the what? The upper limit. Done. Now just connect the box, connect the vertical lines to make a box, to make boxes, okay, and then add the ranges up. You are done with the what? Box plot. Are we done? No. We have remaining what? The outliers, right? Outliers are 16, right? 16. Where is 16? This is the 16, okay? So 16 is an outlier, so mark it as an outlier. And again 90 is an outlier, right? Here you go 90, so 90 is considered to be an outlier, so you need to put a cross there at 90. Now it's done. That's it. Okay. Next is for part D. For part D, they're asking to compare the distribution of the weights of red kangaroos taken in February with the distribution the weights of red kangaroos taken in December of the same year. Fine. So that means they are asking to compare the distribution, like how their weights are distributed, like how these weights varies in the month of February and in the month of what? December. You need to compare it. Okay. You should interpret your comparisons in the context of the question. That means we need to interpret like we will compare statistically, but we will make comment on the context of the question. Based on the context of the question, we will make comment based on the context of the question. Okay. So for comparisons, always keep in mind we have to do comparison on two things. How many things? Two things. The first comparison has to be made on measure of location. Measure of location means mean, mode, median, or quartiles. Okay. We have to make comment. The first point is to make comment on the measure of location. Second point is that we will be making comparison on the measure of spread. That is, it can be variance, it can be what? Standard deviation, it can be I keyword, that is inter-quarter range, it can be also the range of the whole data. Okay. And the third point would be we will make comment on the what? On the context of the question. This is how 3 marks. Okay. So the first thing, we need to make a comment on the what? We need to compare that measure of location. This can be perfect, would be median. Median is perfect since we know the box plot. Box plot represents the median and quartile, so better consider quartile, the average quartile, which is the median. Okay. So you can see that median for December, it's greater than the median in February. Median weight in February. So that means on average kangaroos gain weights in the month of December, that is in the winter season. Okay. They gains weight, and basically in summer they loses weight. This is what we can comment on the context of the question. Okay. For part, isn't it part B, C? It's D. The box plot was on part C. This is part C, and now part D. Okay. For part D, what we can say is that median, right? Q2 in the month of what? February, right? In the month of December is greater than the Q2, the median in the month of what? The month of February, right? You can see it from the box plot easily. Okay. Q2 in the month of December, it is greater than the Q2 in the month of February, right? Okay. So on average, since it is the measure of location, so on average. And we know that median, why I'm saying on average, because median is basically a measure of what, location, and it measures the central tendency or the average. It is also a measure of what, the average of the data. Okay, so on average, the kangaroos loses weight in the winter. They loses weight in the summer. Okay, summer is basically what, February, right? In the month of February. Okay, that's it. And then we need to make a comment on the measure of what, spread. So for spread, you can consider the range or the IQR. Consider the IQR, that will be better. So IQR, again, what we can say, IQR of the weight of kangaroos in the month of what, in the month of December. In the month of December, it's what, it's basically how much, 63 minus 45, which is 63 minus 45 is 23, right? 23. But in the month of February, it is what, 58 minus 42. So 58 minus 42 is basically just 16. Okay, so that means in the month of December is greater. You can mention IQR of the weight of kangaroos in the month of December is how much? It is 68. That is 63. Sorry, 63 minus 45. It's not 18. 45. That would be what? 18. Yeah, it's 18, which is greater than the IQR of weight in the month of what? In the month of February. Fine. Which is, in the month of February, the IQR is how much? 63 minus 45. It was for 63 minus 45. It was for December. For February, it is 58 minus 42. 58 minus 42 is basically 58 minus 42. This is basically how much? 16. So generally, on the winter, that is on December, the weight of kangaroos varies more. Okay, the weight of the kangaroos varies more. That's it. This is what we made a comment on the measure of location, and then we made a comment on the measure of spread, and based on these comparison, we did statistical comparison, and then we made a comment on based on the context of the question. Okay, I wrote a bit in an explanative way. You can make it more confined, no problem. for 3 marks, you can make it more confined, it will be fine. So that was all about part D, and that's the end of question number 2 from October 2023 statistics 1 paper. Okay, fine.